This reaction is a Diels-Alder reaction, so I'm giving you that up front. It's a little tricky, so if you haven't worked out the Diels-Alder in your head by working book problems, maybe the 2 video problems before this one, I recommend going and trying that first. All right, this is a little tricky. So it's a Diels-Alder, hit pause, figure out what the product is, and come back and I'll go through it. Okay, so it's like I said, it's a Diels-Alder, so you've got to have a diene and a dienophile. Here is the diene, and here is the dienophile. All right, you might say, well, wait a minute, that's S-trans, and it is. But remember, I'll put this in black. I'm thinking the red is a little hard to see. So remember, there's an equilibrium, and it lies quite far to the S-trans. Generally speaking, the S-trans is about 85% of the mixture, and the S-cis is about 15, and that obviously depends on what the substituents are on it. But most of the time, it's going to be mostly S-trans unless it's locked. But you always have a little bit of the S-cis, and that's what reacts. So this equilibrium takes care of getting your Diels-Alder diene. So I'm going to number this the way I've been doing. 1, 2, 3, 4. And then I'm going to change this over to letters A, B, C, D, E. Okay, so obviously D and E are going to make bonds to 1 and 4, and the question is, how does that happen? And so what you need to do is sort of redraw this, and that's why I said it's tricky. The reaction can't happen like this. It can't happen with an S-trans diene, and it can't happen with the dienophile way down there. Remember, in all these mechanisms, if you just think about, right, so here's our base, and here's an acid. We might just draw this like that, right? You've seen curved arrows for acid-base reactions like that. Those curved arrows, you know, the base isn't like throwing the electrons out there. What this really means is the base has to move around here, line up right with the AH bond, and then it can react. And they actually have to collide. So the basic atom has to get close enough to the H to make a bond, right? In solution. Like for us, the base might be, you know, here, it might only be 100 nanometers away from this molecule, which to us is, you know, we can't even see that. We couldn't see them separated. But 100 nanometers for molecules may as well be like 20 miles. All right, so these arrows mean the atoms are moving within bond distance. And so you have to think about the conformation. The S-trans diene is going to have to go around to the S-cis. And we're going to get bond to O. And now this part is going to have to rotate down around to make. So this is going to be A, B, C, D, E. So we have an ester there. Now this is going to be the conformation that reacts. And so our bond between, we're going to get new bonds, but a new bond between D and 1 and E and 4. And this is just the only way for these to come in. There's not enough space for E to bond to 1. Electronically, you might actually want E to bond to 1. But the molecule is constrained by being linked together. All right, so then the mechanism is that. So we get, standing in your way, sorry. Remember, you're going to get a cyclohexene. Every Diels-Alder is going to give you a cyclohexene. Here's the cyclohexene. 1 is going to bond to oxygen, B, C, and that one is D. Here's our ester. Okay, we're not done yet. We have to get some stereochemistry in here. Right now, we don't have any stereochemistry shown. And I botched this. Look at this. I screwed this up. All right, the double bond, the DE, the dienophile is trans. So it's got to be trans here. And it's got to be trans there, all right? So we can't change the stereochemistry of the dienophile alkene, either in wrapping around here to do the Diels-Alder or in getting the getting the Diels-Alder adduct. So if this group's back, the ester has to be front. If that group's forward, this would have to be back. And you could get both. And then the way this is going to work out, the exo, sorry, crap, the endo rule. I think I've been calling it exo. The endo rule says that that has to be, those two have to be trans. All right, so that's the full product that you get there. This stereochemistry is not going to be as important as this stereochemistry. All right, the dienophile is trans, so this has to be a trans ring fusion or a ring substitution. Has to be trans. I initially drew it as cis. I drew it as cis because it's easier to draw, right? Don't do that. That's a classic mistake. It's just easier to put the group there than to put it here, but you can't do that, right? That means that the double bond cis, it's not the same molecule.